In this video, I'm going to answer some series circuits and parallel circuits. However, this is a new digital version. So this one here, I prepared for you by hand, and now I have this nice format. This first circuit, we have R1, R2, and R3 in series, and is asking what is the total or equivalent resistance of the circuit. For a series circuit, the total resistance is equal to the sum of all resistors that are in series. In this case, 2, 5, and 4 ohms. The result is 11 ohms. The interpretation for this is that this value, this resistor, can replace all those three resistors in this circuit. Also, this total resistance will require the same amount of energy from this voltage as those three combined together. This is a series circuit with 2 resistors and a total voltage of 30 volts. And here is showing the voltage drop on this resistor as 5 volts, and is asking what is the value of the voltage drop on the second resistor. For a series circuit, the total voltage is equal to the voltage drop on each resistor. The total voltage here is 30. The voltage here is 5. Therefore, the voltage on this resistor is 25 volts. In the series circuit, is asking the current flowing through each resistor. In a series circuit, the current flowing through this circuit is the same. So the total voltage is equal to the voltage that is flowing through this resistor, this one, and the third one. Now here is given the value of IT, which is 3 amps. Therefore, the current flowing through I1 is 3 amps, through I2, 3 amps, and through I3 is 3 amps as well. In the series circuit, is given the total voltage, the voltage on this resistor, the voltage on this resistor, and is asking to calculate the voltage on this resistor. In a series circuit, the total voltage is equal to the sum of the voltage drop on each resistor. So the value for VT is 15, V1 is 5, V2 is 5, and V3 we need to calculate. So 15 is equal 10 plus V3, so V3 is also 5. In this circuit, R1, R2, and R3, they are connected in series, is giving just the voltage on this resistor, R3, which is 2 volts, and is asking the total current flowing through the circuit. In a series circuit, the current flowing in the circuit is the same. So the current flowing through here is the same here, here, and here. So we have this information right here on this resistor, and we can calculate the current on the resistor 3, which is the voltage across this resistor over the value of its resistance. So here we have 2 volts over 10 ohms. So the current flowing through the third resistor is 0.2 amps. So since they are all the same, so we can state that IT is also equal to 0.2 amps. In this circuit, R1, R2, and R3 are connected in series and connected to this voltage of 360 volts. I know it's a lot. And is asking to determine the value of this resistor. There are different approaches that we can solve this problem, but one that we can use here is the current that is flowing in the circuit is the same. So here is 6 amps flowing here, and this is also 6 amps. So I can calculate the voltage drop on resistor 2 by multiply the resistor 2 times the current flowing through this one, which is 6. And for V3, I have R3 times the same current. Making the substitution, that will be R2 is 12 times 6, same current. And for V3 is 36 times the current, which is 6. So the voltage drop on resistor 2 is 72, and the voltage drop on resistor 3 is 216. For a circuit series, the total voltage is equal to the sum of the voltage drop on each resistor. So doing the substitution, V2 is 72, V3 is 216, adding them up is 288. So then the voltage drop on the first resistor is 72 volts. Finally, to find R1, I'm going to use Ohm's law, which is V1 over I. Because current is the same, I'm not going to label I1, I2, or R3 because it's the same. So in this case, R1 is 72 over 6. So R1 is 12 ohms. These 3 resistors are connected in series, and we have a couple of information about each one. In this resistor, we just have the value of the resistance. Here we have resistance and current, and here we have just resistance. And we have the total voltage, which is 48 volts. The current is provided, which means that the whole circuit is, the current flow in this circuit is the same, which is 2 amps. So V1 here is V1 is equal R1 times I. So V1 is R1 is 4, I is 2, so V1 is 8 volts. Likewise, V3 is R3 times I, and V3 is 12 times 2, and V3 is 24 volts. To check for correction, you can do this. VT is V1 plus V2 plus V3. We know that VT is the total voltage is 48. So let's see if that's gonna happen. So I have here 8 volts. V2, I don't have the value, but this will be 2 times 8, 16 volts, and V3 is 24 volts. So when we add all these, we have 48 volts, which is the same of this value right here. This is our last circuit in series. So we have those 3 resistors, and is given the total resistance for this circuit, and is asking for the current flowing in this circuit right here. Is asking for R1, I1, but it's the same current, and is asking for R3. First, to find this value of this resistance right here, we can use this formula. The total resistance is equal to the sum of all the resistors they are in series. Total resistance is 30. R1 is 10, R2 is 15, and I'm looking for R3. So 10 plus 15 is 25. So R3 is 30 minus 25, which is 5 ohms. To find this current, we can calculate the total current for here using the total voltage over the total resistance that was given this problem. The total voltage is 120 right here, and the total resistance is 30. So my IT is 4 amps. Since IT and I1 and all the current flowing in the circuit is the same, so I can say that my I1 is also 4 amps. So the current flow in this resistor is 4 amps. Parallel circuit. So here we have that is showing only current. So here is a joint. So the current that enter in this joint, which is IT, is equal to the sum of the currents leaving the joints. There is a formula for that. The sum of all currents in a joint is equal to the sum of all current out of the joint. In terms of equation, so IT is equal I1 plus I2. So IT is 5 plus 10, and my IT is 15 amps. Parallel circuit. So here we have 2 resistors in parallel, 3 and 6. To find the total resistance, or the resistance that is going in value, replace those 2 resistors, we have to add the inverse of those resistors, like this. The best way to do it is set up R is equal 3 inverse plus 6 inverse, and the result is inverse. Your first step is to find the inverse key on your calculator. In this case, the inverse key is this one right here, 1 over x. Sometimes you can see 1 over x as a key on your calculator, or x minus 1. Either way. So I'm gonna do for you. Here is 3 inverse plus 6 inverse equal, and then you do inverse one more time. Inverse. So my answer is 2 ohms. Parallel number 3. These 2 resistors are in parallel, and this is the voltage across each resistor. So you see the terminals of this resistor are connected directly to the terminal of this voltage. Therefore, the voltage on this resistor is the same. Likewise, this one is the same. This is your answer. Let's go to the next problem. Now we have those 2 resistors in parallel, and we have more information. We have the current that is coming to this joint, and then we are gonna have here a current come down, flowing through this resistor, and another one flowing through this one. And this problem is asking what is the value of the total voltage of the circuit and the equivalent one. Okay, we can calculate the current flowing through resistor 2 by using Ohm's law. So it's V2 over R2. So the current I2 is 2. Now here we have a joint. So the sum of the current in the joint, in this case is just IT, is equal to the sum of the currents out. So it's I1 plus I2. My IT is 4. My I1, I don't know. And my I2 is 1. So my I1 is 3 amps. To calculate R1, we know that the voltage right here is the same as here. So this is 12 and this is also 12. There's all 12. Because this is 12, this is 12, and this is 12. The current I1 is 3. So to find the resistance R1 is V1 over I1. So my V here is the same, which is 12 because it's in parallel. My I1 is 3 amps. Therefore, my resistor is 4 ohms. Great. Now that I have my resistor here, which is 4 ohms, this is 12, and there is one question to find the current, the total current of the circuit. So you are setting up like this. Is this resistor 4 inverse plus the second resistor is 12 inverse, and inverse one more time. Okay, calculator here, and 4 inverse plus 12 inverse equal inverse one more time, and my total resistance is 3 ohms. In this parallel circuit, is asking the value of R1, the value of R2, and the current flowing through R2. And what was given here is the voltage across this resistor, the total current that is entering this joint, and the current that is leaving this joint. So let's start with I2. So the sum of the currents in, which is IT only, is equal to the sum of the currents out. So my IT is 2, I1 is 1, and my I2 is 1. To calculate R1, I'm using Ohm's law. R1 is V1 over I1. So the voltage here is 24. So R1 is 24 over the current that is flowing through R1, which is 1. So my R1 is 24 ohms. My R2 is the same thing, like in same approach. So is Ohm's law, which is 24 over I2, which is 1, and my R2 is also 24 ohms. So both resistors are the same, 24 ohms, and the current 2 here is 1 amps. In this parallel circuit, it's just asking what is the value of V1 and V2. Since they are in parallel, so V1 is 110 volts and V2 is also 110 volts. In this circuit, it's about current in a parallel circuit. So here is a joint. The sum of the currents in is equal to the sum of current out. So my in is 50 and I1 is 32, and I want to know how much is my I2. So I2 is 50 minus 32, which is 18 amps.